Intersection of polar graphs sounds complicated, but we will spot you the graphs, so that will make things a little bit easier. In calculus, you need to find the intersection of two polar curves and the value of theta where the polar curve is at the origin. That's yes. To do this, we will use what we learned when we solved trig equation. We're going to put some things together in this unit. So this is one of those days where, hey, if you understand everything you're supposed to know up till now, today will be easy. But that's a big if. All right, determine the values of theta where the graph of r equals 5 cosine theta. So let's see, that would be a circle in the x direction. Intersect with the graph of r equals 2 plus cosine theta. That would be a limacon. So that would be this curve. And so in one sense, you're like, oh, I know where they intersect. They intersect right there and right there. I'm done, right? You found them. Except it wants the theta where that happens. So what we'll do is set the equations equal to each other, because they both have an r equals. So if r equals r, then 5 cosine theta equals 2 plus cosine theta. And now this is just a problem from when we solved trig equations. So I'm going to move the cosine over. One of my favorite algebra mistakes of all time right here. 5 cosine theta minus cosine theta is 4 cosine theta. What is my favorite mistake to make that equal 5, right? Cosine thetas cancel each other out. No. 5 of them minus 1 of them equals 4 of them. What do you want to do next? Divide by 4. So cosine theta is 1/2. And then we think back to the unit circle. Cosine theta is 1/2. Let's see, that would be at pi over 3 and at 5 pi over 3. And if you look at our picture, I think that's believable. That's pi over 3. And the one down here is 5 pi over 3. So the pictures will help you confirm your answer. You can't really get your answer from the picture, but you can make sure your answer makes sense using the picture. Number 2, where does 4 plus 4 sine theta, that would be the big one here, intersect with the graph of r equals 2? That would be the little circle right there. Well, set the two things equal to each other. See if you can finish that one. 11 pi over 6. And that matches with what you see, I think. Right? I'd believe that that's 7 pi over 6. And that that's 11 pi over 6. So on these problems, you get a visual check at the end to make sure your answer seems correct. Number 3, find the values of theta where those two graphs intersect. 8 cosine 2 theta equals 4. Again, you can look at the picture. Maybe we look at the picture ahead of time even. There's the circle r equals 4. And we got a rose with 4 petals. I'm not going to highlight the whole thing, but The rose with 4 petals. Goodness, how many intersections does this one have? 4, 5, 6, 7, 8. So I should have 8 answers for this one. Again, we get a little check ahead of time. Should have 8 answers to this. Cosine 2 theta equals 1/2. So that means 2 theta needs to be, let's see, cosine's equal to 1/2 at pi over 3. And at well, let's just stop there because I can figure it out. I can use the picture, right? I don't want to say I don't want to use my equations, but I can use the picture. So pi over 6 is the first one, and the symmetry makes it look like it's all of the over 6's. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. But it's also the over 3's. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. So use the pictures and the equations kind of together. Yep, that's 8 answers, and we got 8 intersections on the graph. Back page, calculator. Same process. So set the r's equal to each other. 3 minus 2 cosine theta equals 5 plus cosine theta. So if we move things around, it's like how many algebra steps can we do at once without messing things up? Subtract 5 from both sides, add 2 cosine theta to both sides. Negative 2/3 equals cosine theta. Okay, maybe we could have expecting 2 answers out of this. Cosine equals negative 2/3. That's not a nice answer. How do I figure out what theta equals? Right, that's not a unit circle thing. So I need to do inverse cosine of negative 2/3. It really should have said, because it doesn't specify whether we want to be in degrees or radians, but we want to be in radians. Although degrees you could make more sense of an answer in degrees, because you can tell by looking at what that angle is in degrees. In fact, if you wanted to sort of check your work, 131 degrees. Yeah, I'd buy that. I can't tell by looking exactly what it is, but 131 seems reasonable. Now, there's another angle over here. How do I figure out what that angle is? It's 2 pi minus, so like the symmetry here, this would also be 2.3, but that's not how we measure them. We want to measure it this way. So that angle would be 2 pi minus the first angle that we got. So you have to use your picture to kind of figure out what's going on. 2 pi minus first answer, 3.983. And it said 3 decimal places, so 2.301. Number 5. Again, same type problem. And again, we can kind of see from the get-go that we'll have 2 answers. First quadrant and second quadrant. Where does 5 minus 2 sine theta equal 2 plus 3 sine theta? So again, move things around. Hopefully you can do that quickly without having to write out every single step. You just don't have time, especially when you get to calculus. You've got to be able to make a couple steps of algebra quickly in your head without writing out, you know, minus 2, plus 2 sine theta, plus 2 sine theta. Most of you are fine to do that. Okay, sine equals 3/5. That doesn't sound like a unit circle value. So calculator, plus it said calculator from the get-go. Get back to radians. Inverse sine, 3/5. 0.644. But that's that angle. How do I figure out this angle? What's that? Similar to what we did last time, but now the symmetry is this part is 0.644. So I need to do pi minus my first answer. Pi minus answer, 2.498. Like, again, working in radians is tricky because it's like I don't really know what that is. Suppose if you really wanted to check your answer, you could convert it to degrees. Wouldn't that would be the other way though? Times 180 over pi. Be 143 degrees. Yeah, that seems reasonable. Again, we want your answer in radians, but your brain doesn't really think in radians. Last one. The graph of r equals 3 minus, in fact, this one's a little different, so if you've zoned out thinking you got it, zone back in here. The graph of r equals 3 minus 6 sine theta is shown below. Find the values of theta where the graph is at the origin. Okay, so we only have one graph. We're not looking for an intersection. Well, we sort of are, actually. What's going on at the origin? Like, that's where the loop starts, and that's the calculus reason why we need to know where that happens. You're kind of ahead of the game there. What's the coordinates of the origin? Put it that way. 0, 0. Although really r could be anything. Nope, said that wrong. If r is 0, it doesn't matter what theta is. Right? If r is 0, it doesn't matter what theta is. Because you hadn't gone anywhere. R is 0. So it's sort of the intersection of the origin equals the equation. So 0 equals 3 minus 6 sine theta. So it's kind of like the other ones where you just set the two equations equal to each other, but one of the equations is r equals 0. And this one's a little harder to tell graphically. Let's see, sine is 1/2 at pi over 6 and 5 pi over 6. And so that's all that we need. That's when it goes through the origin. But for calculus, that's where the inner loop starts and stops. It starts at pi over 6 and it ends at 5 pi over 6. And so in calculus you can use those to find the area of the inner loop, or the area of the whole thing, or the area of just the point minus the inner loop. So you got to know what those angles are. But for us, treat it as any other equation where you just set the two equal to each other. The two r's equal to each other. Alright, so I think today is sort of a step backwards in terms of difficulty. Worksheet 6. And again, for most of them, you kind of have answers to let you know where if your answers make sense. And then you can start the review if you want, and we'll talk about the review and the test tomorrow. And the test, again, is on Wednesday.